Alright, so we're going to look at greatest common factors. We're specifically going to look at exercises 2 through 12 in the textbook, where we pull out greatest common factors from terms. So if we look at number 2, which is x squared plus 2x, we'll look at this to get a definition at what we're doing. So in the background, we had our distributed property that we learned. And that says that we distribute what is being multiplied by a sum to each term in the sum. Well, in this case, we're starting with the right-hand side. We're starting with the RHS, right-hand side. You'll see me abbreviate this a lot when talking about things within equations, because there's a right-hand side and a left-hand side. And even in mathematical papers, they'll just write RHS or LHS. And so here we're starting with the RHS, and we want to move or change this to the LHS. And so the part that we're looking for is A, which is common to both terms. And we call this part the greatest common factor. Greatest common factor, abbreviated GCF. So if we look at the multiplications that go into making number 2 here, we have x times x plus 2 times x. So both sides have an x, and they only have one of them. So the GCF is x. Alright, let's use this idea. Work our way through. Let's look at number 4, which has some numbers. So we have 16z squared minus 20z. We can kind of think of this. We can think of this. Sorry, kind of is probably not as specific as we need. But we can think of this as the coefficients and the variable terms, right? We can separate them out. So we'll look at the coefficients here in yellow. So 16, and we'll make a factor tree. It's 4 times 4, and 4 is 2 times 2, and so we get this. So all said and done, 16 is 2 to the 4th. 20 is 4 times 5, or 2 times 2. So 2 times 2 times 2 times 5, 2 times 2 times 5, sorry, 2 times 2 times 5 is 20. And so our factor trees, these ends, multiply together to make the number. So this has 2 squared. Well, if we use the same rule we used for variables, we take the smallest power of each number we see. In this case, it's 2 squared. So the shared numerical or coefficient is 2 squared, which equals 4. The first part of our GCF is going to be 4. We're going to come back and we're now going to look at the variables. We'll have a z and a z squared. And as we saw in the previous part, we take the lowest power, which is z. And so the GCF is 4z. Alright. Let's look at a slightly longer one. And we'll look at number 6. Yeah, 6 is good for us here. And that should show us all we need, because what we have now is we have 3 terms. And 2 variables in those 3 terms. Now you'll find the variables are quicker to see, so let's get our variables done first. First term has an x squared and a y. The second term has an x and a y squared. And the third term has an x squared and a y squared. So they all have x and y. And the smallest power of y is 1. So y to the first. And the smallest power of x is x, just x. So the variable terms in this GCF are going to be x, y. So the variables are nice. You look for the smallest power that they all have. If there's a variable that's not shared, and we'll look at that in the next example, you can't take it. It's not common. We want the greatest common factor. Now, if we look at our numbers, we can use the power trick. One of the things I like to do is, hey, I know 4 multiplied by 2 gives me 8. So a common factor between these two numbers is 4. And I know 4 times 4 is 16. So, hey, they all have a 4. And this one here, 4, is the biggest number that we can use. So it's good sometimes to look at your smaller numbers and see if it's multiples of the other numbers. Won't always be. And that saves us from making that tree. So in this case, our GCF is 4xy. Alright, and let's look at one more so we get a good handle on our GCFs. And what I want to look at is what happens when you have, what I'm going to do is I'm going to make an alternate form of number 12. Z cubed y plus 6z squared x plus 18z. So I'll start to do the same thing. Variables go quicker, so I'll look at the variables first. And they all have a z, but only this one has the y. The y is only here, the x is only here, and this has no x and y. So the only variable we're going to take is z, because it's the only thing common to each term. And we'll take the lowest power of z, which in this case is z to the first. Now I'm going to use my same trick with my numbers again. Hey, 3 multiplies into 6, and I know 3 multiplies into 18, so my GCF would be 3z. Alright, so that's the basic concept behind greatest common factors. Of course, as with anything in mathematics, we can build it up to more complexity to get more done. And we're going to see how we can use greatest common factors to factor out trinomials and larger term polynomials so that we can get their multiplications. The game for us is anything that we've done forward we can do backwards. We've multiplied polynomials, so now we want to pull apart those multiplications.